Okay, so let's get into this kind of motor. This particular style motor I've only seen with Carrier products. As you can see, we have a model number here, which is Carrier's part number, that HD52. I apologize, guys, I'm holding the camera. But the HD52MQ124. So that is Carrier's model number. As you can see, the wiring diagram is a bit confusing. This is going to look much different than how it functions. And how this one functions is exactly like an X-13. So it is essentially an X-13 motor. I'll show you what a normal plug-in style looks like and how to correctly wire these up so that you could use, say, a universal or a drop-in replacement. As you can see, it's a bunch of wires, and I'll show you in a minute what a normal X-13 motor looks like. On the end, in which, again, guys, I'll show you what I'm talking about, Carrier puts these smaller terminals, these smaller connectors that a lot of people don't use. Another thing you'll notice about this motor is the mounting style. This kind of bracket is hard to find if you're going to get a universal motor. Now, we were able to find where you purchase a removable bracket that lines up with this style. I have come across some rigid brackets that will actually line up with these holes. Obviously, when you're going to replace this with an X-13 universal, make sure that you match your specs. Like we mentioned before, it's not just about the wiring, it's also your specs. They have boards or modules in them, and those are going to contain the capacitor or capacitors. So if you have a motor like this in your system, it's not going to have a capacitor. The X-13 or the full variable speed, known as a electronic communicating motor. These are constant torque or X-13. Make sure if you have a gas system, or some of you propane, it's going to be 115, 120 volts. So make sure the voltage lines up. Then we're going to make sure that our horsepower lines up. Sometimes you kind of have to hunt around a little bit, but that's our voltage on that side. And then on this side, you can see 1 HP. Now, I've had several customers, especially with condenser motors and even some blower motors, they'll flip the 1 HP, which is horsepower, but they'll flip it with pH. So if you see the number 1 and then pH next to it, it's not saying it's 1 horsepower. That's simply stating that it's single phase. So double check and make sure you are seeing that this is HP. Okay, so what we're gonna do is we're gonna go ahead and take that Carrier motor. I'm going to take it up to the bench at the front and compare them side by side so you can see how you wire them up. And I'll go ahead and draw a diagram for you as well. So let's take a look. Okay, so as you can see here, most X-13 or what we call constant torque motors have a plug style like this. There are some where this plug is actually external, but this is what most of them look like. You've got C, L, G, N, and then numbers 1 through 5. What we're looking at here is C is going to be your common. Okay. L is going to be your line. G is going to be your ground. And then N will be your neutral. Now, if your unit is an electric air handler, this neutral actually becomes your other leg of 120. And that's not exactly how it works, but essentially what we're doing here is 120, 120. So if your unit is a gas unit, you're going to have just the one leg here of 120, and then your other line would be neutral. These numbers right here indicate speeds ranging from low to high. So from, 1 being your high speed your low speed, low, to 5, which is going to be your high speed here. We're going to look at that with the carrier motor so that you can see how we're wiring it. And they label it a little strange. We'll get into that in just a second. Okay, so here as we look at these labels, I know they're a little hard to read on here. Let me zoom in just a little bit. Hopefully we can kind of get closer to see that. See if I can get it to focus. Okay, so as we mentioned before, when we're looking at this wiring chart, it can definitely be kind of confusing to match up to, you can see how simple this one is charted out here. So on the speeds 1 through 5 listed on here, they are listed as M. So we've got M1, M2, so on and so forth. So from 1 to 5, these are going to be the same speeds as 1 through 5 on here. And I was actually curious, so I went and checked out the specs for these motors through the manual, and they are indeed the same. Sorry guys, I'm having to hold this because this label is being a bit of a pain to focus on. Then whereas a lot of people use blue for common on their wires, they actually use green on theirs. The green is going to be your common line here, where the C is here on your X-13 harness. So where it's labeled under the green as common, that's going to be your common on the top 4 here on this motor. So just keep that in mind because there is blue wires on both of them, and literally blue wires on the speed and the common line ground on this plug. So we need to keep track of that as we start explaining how this wiring harness is going to go. And then, of course, here on the top, as you can see, they have neutral next to the white and L or line next to the black. Those two colors are going to be exactly the same on here. And as you can see, they are labeled the same, N and L. So make sure you match those with the 2 on the top. Okay, so earlier we talked about the differences in harnesses of a carrier versus, well, in particular, this kind of motor from carrier. We mentioned the differences in the plugs. Obviously, I don't have those smaller plugs here. I do have an example so I can show you the difference. When plugging in our new X-13 motors, you're going to have harnesses like this instead. And don't worry, they're only going to plug in exactly how they need to. You can see there's only a certain amount of pins on there, so it's going to fit in exactly like it should. Same with your speeds here on the bottom. We're just going to plug those in. And then now make sure always that there's a good snug connection. So the easiest way I found, and what I do when I'm in the store, is I splice. And the reason for that is it's just so much easier for the customer because, they look at it and their eyes get wide because obviously it's completely different between the two. And they're kind of looking at it like, whoa, what are you talking about? Okay, so remember earlier when we were talking about the harness sizes between the two, what I mean by that is the actual plug itself and the physical size. So as you can see here, this is a much smaller terminal than this plug. You can see that this is going to be larger. Now, while you can crimp these down to make them fit where these smaller ones went, I don't like to do that because especially with electrical, and you know, the golden rule, and that is if it ain't tight, it ain't right. So rather than crimping them on the actual terminal itself, it's best to just go ahead and splice these together. And if you're going to splice, I highly recommend using a heat shrink butt connector. But cut these back and usually leave yourself a little more than less. We're going to cut them back. We're going to, get the wire exposed, and we're first going to make our mechanical connection, meaning you're going to, and I cannot get this to focus on here. Sorry, guys. There we go. So we're going to crimp here and then crimp here as we join the two together. Always remember to do it one by one because you can easily confuse the blue wires since there are two blue wires here, right? So one by one, systematically, we're going to connect them. Now, having just a mechanical connection between the two, I like to crimp both sides and the middle just to make sure. But these are really going to be helpful because you're going to use heat, which a heat gun is always handy to have anyway. Preferably a heat gun, but if you just have to have a lighter, just be really careful. What you're looking for is a thin bead of glue that goes all the way around. Okay, you're probably looking at the two differences and wondering, how do I even tackle this? The best way I found is to just systematically go through and tag each wire with these handy little guys here. I mean, you can use whatever you want, paper, tape, whatever strikes your fancy, but just label them first so that way you know, usually on each side, that way just boop, 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 all together, crimp them, and then you're good to go. Okay, so as we spoke about before, just kind of deciphering these wiring diagrams can be a bit tedious. Since we know based off of our plug from our other constant torque motor brand, you know that, what each one's going to be, C, L, N, G, So you're going to write those out on these tags and then just go ahead and tag these guys that you've removed. You're going to have those individual terminals like I was showing earlier. So once you figure out which is which, according to this wiring diagram, just label those out so that you can match them up easily with this. And that way you're not having to go based off of colors and potentially get confused and blow out your new motor. Now, if you are colorblind, this could actually be very tricky, even if you're not colorblind, because as you can see here, the difference between the two grays are extremely dangerous. They're saying that this color, let's see if I can zoom in here. They're saying that this color on the right is black and this color is gray. Now, if you were colorblind, or even if you weren't, they can look very much both like black. And obviously here on the wiring diagram, that's really important that you do not mix the gray with the black, because your black is your high voltage. That's 120 volts. If you put, say, the gray where the one black wire here is on the top harness, that's not going to work. It's definitely going to blow out your new motor. So just pay attention to that, or if you're not sure, maybe ask someone that could tell the difference. I can definitely make it out, but not everybody can. I'd hold it up against something bright in color, because the difference here is blowing out your motor, because this is 120 volts and that is 24. So really double, triple check. And if you're dyslexic like me, that can make it extra fun. So I have to have a system when labeling things to make sure that I am doing it correctly. That way I don't have to worry about blowing out, somewhere between a $350 motor to upwards of a $1,400 motor. So just beware of that when you are labeling these. So if you really want to make this easy on yourself, do this on both sides. So that way you can line them up perfectly and you haven't made a mistake. But always double, triple check that your wiring is correct before you actually splice them together, for obvious reasons. You can also see why this is important, because there's also 2 blue wires here. And this one is your common wire, and this is a speed. Even though this is, say, your one leg of 24, and this completes your 24 here in your speed, when a speed is your common, this is going to run on a different winding. And you remember from before when we were talking about how PSC motors work, there's always going to be your start and your run. So remember, these are not going to run on the same winding. Therefore, you need to make sure this will be tied in with your common, and which we've labeled it also on our other wire. So make sure that your common is lined up. And then, as you can see, we also have a blue on this one, which is one of your speeds. So always make sure that you do not just use 2 of these and, accidentally connect this up with your other, or connect this up with your other blue wire. So once we've got our labels on both sides here, what we're going to do is we're going to splice these onto the other motor. Now, I'm not going to splice these wires. Obviously, this is a good harness. I'm going to keep it that way for the store because, sometimes people will come in with burned harnesses, and, we'll tell them, hey, we have some. And, it's just very useful for people because those harnesses can run and they can get very expensive. So having the option for us to keep these sorts of things for people, it's just a good idea. So remember, we spoke earlier about how these mounting patterns can be different on these kinds of motors. You can see they kind of have some funky legs compared to some of the normal PSC and X-13 motors. They usually have a flex mount, which I can show you what that looks like in just a minute. But if you're going to try and find a bracket that's going to line up when you are purchasing a different brand of X-13 motor, you're going to look for this style mount. These are specialty mounts. Literally only Carrier does this style. You might be able to find a rigid bracket that might line up here with these bolt patterns. I know that this is called a torsion flex mount. So try Googling it and just seeing if maybe you can find this exact bracket here. Okay, so I've pulled a normal flex mount just to show you. These, let me see if I can back this up just a little bit so you can see here what we've got going on. Okay, so this is going to be a normal flex mount, and you can see that the legs are different. Now, even if a mount might look similar, it might not always work based off of where they have placed the holes on the housing itself. Keep in mind there's some that are going to actually come in closer to where the opening is, and some that are actually going to go further out, like many old style ream and rood mounts that I've seen. The legs are different lengths. And there are actually some, like I have seen some York housings where one of the leg mounts are actually longer than the others. So keep that in mind when you are buying a universal. You're going to want to make sure you pay attention to how the mount looks, because most universal motors, they're not going to come with the mounts like these, how they're welded on. Now you can find some universals that have welded legs, but this is a specialty style motor that only Carrier does. So keep in mind, you can see here, if I can kind of show you at an angle, these are tilted differently. They're going to be a different length from here to here, and you can see how that tilts. Now, you could make any mount work for this. You just need to make sure that the mount can hold a 48 frame motor, which is just going to be the, the distance between the bolts on the motor here, or basically the diameter. Make sure that you are looking at that, because if you cannot line that mount up, that means you're going to have to tap into the housing to make them line up. And that can be a lot of extra work. Now, if you're into doing that, no problem. You're like, hey, I can do it, no big deal. Then, go for it. Just make sure that they're sturdy enough to be able to hold an X-13 motor up, because they are extremely solid motors. I do like these style motors. They're made by US Motors. This is a private label for Rheem. However, this is made by US Motors, also known, formerly known as Emerson. Fun fact, US Motors, the parent corporation, is Nidec. So it's kind of fun learning when you're purchasing these motors. Now, in store, I do have a lot of worried homeowners and new techs ask about the bracket, where it should be lined up. Keep in mind with these style, you are going to have to keep this where you can plug in the connectors. So remember, when you are installing it, adjust the bracket as you need to make sure this comes up above the opening to where you can plug these in without them bending or straining. It's okay that this motor sticks out a little bit, because you're going to balance it with your bracket, and the shaft is adjustable. You can literally put that set screw all the way to here if you need to. So with blower motors, they are an open motor. It's okay when you place the bracket on these if you cover up, say if you need to move it up really, really close to here and you're covering some of this up. That's okay, as long as it has, some air somewhere here to breathe. Okay, so just to review, now that we know how this wires up here and what their wiring diagram is saying, just like the normal style, X-13 motors. Let's just do a quick review. So we've got on this motor, common, line, ground, neutral. Okay, so on the common, line, ground, and neutral, and then below that we have our speeds 1 through 5. And each one of these are going to be labeled here on the carrier version of the X-13 motor. So we've got R, and hopefully it'll at least catch a little bit, but we've got our neutral, which is white, or our other line, black, which is our 120 for gas, or our other line for 240. These are our speeds. So we've got red, orange, blue, yellow, gray, and then green is our common on this one. So this M and then the number after it are our speeds. So as we mentioned before, go by numbering and labeling what each blue wire is, because there's going to be a blue wire here at the top, and there's going to be a blue wire here on the bottom. Make sure we label. So we've got our common, line, ground, and neutral. So remember, neutral is going to be white on both of these motors here. When you're switching over to a 240 volt motor, that neutral actually becomes an additional 120. And these motors default to 240 volt. So they're going to come with a jumper. And it is a little confusing because on here it says 230 volt. And all that's letting us know is that this defaults to 230 volts. So with that jumper, you're going to open that and you're going to place that jumper in here to make it 120 volts, same thing. So always remember to do that with these style motors, because the original one is going to automatically be whatever voltage it's supposed to be, which is labeled here. So that brings us back to our other point from earlier, to make sure that you get the voltage correct. Check all of the specs on your motor and make sure that they're correct. Make sure you read all the directions on universal motors. A lot of them are set for 230, and then you're going to make it 120 for gas by using that jumper. So always pay attention to the numbers on the motor. All right, everyone. Thank you so much for joining us today. And if you have any other questions, feel free to leave them in the comments below. And please help us out by leaving a like, or if you'd like to see more of these, subscribe. Thanks again, guys, and have a wonderful day. Bye-bye.